Let's talk about more malware stuff. Now, a couple days ago, yesterday, it was yesterday, I put out a video going over the Rust malware that I'm building. I spent a very small amount of time on the C2, mainly because I planned on doing a full video like this to kind of go over how it's built, different things like that, and to kind of talk about my approach to the C2 going forward and some of the different things that I want to experiment with. After all, this is not going to be a product that I release. This is something that I'm kind of using as research, which is an awesome way to approach malware development, in my opinion. So let's start with the client. I know we're going to be spending most of our time talking about the C2, but to kind of get a feel for how I'm interacting with the C2, let's take a look at the client. So request is fairly similar to fetch, for example, in Node.js or the basic HTTP functionality within Python. It is literally just an HTTP kind of client. So you can send GET request, POST request, delete request, whatever. It takes a URL as input, so that's what I'm using this format for. And you can send bodies along with a post form, a post request, blah blah blah. Very very simple stuff. So I'm going to go ahead and run this. Right, it will build that. And then we can go ahead and fetch it on our victim side, not our reg query. Let's go back up here. I was doing something else there. There we go. So let's go ahead and pull it down and do that. Looks like it ran successfully. Let's take a look at our server. Yep, so everything ran fine. Should have pinged. Okay, so the C2 is fairly simple as well. If you've ever built any REST APIs in your life, it's a very simple approach. You set up an endpoint that is going to serve as like a URL, and that URL is what you're going to hit in order to do a thing. So I might have a URL to upload user information to a database, or I might have a URL to download a piece of malware. They are all functionally the same, and that's kind of the tangent that I would like to go on, but I'm not going to go on it right now. Most threat actors, or at least a lot of threat actors, I'm not going to say most, but I'm going to say a lot of threat actors set up their C2s very similarly to an API or an enterprise web application, because you basically want all of the traffic to look the same. So if a defender is looking at the traffic and they see a download to, for example, let me show one of my... Let's see, let me go to function main. So if we're creating our routes here and I see a download from download/update, okay, that doesn't look that suspicious. That URL doesn't look that suspicious. If instead I did download/malware, now that would obviously not be great, but I'm never going to do that as a threat actor. I'm going to make it download/update. So the more you make your C2s look normal, the more you use, like I'm using Poem, for example, which is the exact same backend that I use for a lot of my enterprise web applications that I build. The more you make it look normal, the better. That's ideally what you want to do. So when we're creating this listener, we're setting up our API and we're adding all of these routes right here to our API. So each one of those is legitimate URLs that we can hit and do certain things. And this callback right here that we're using within Git, that is, that's why it didn't work, because I tried to send a post request. Duh. Let me go ahead and change that real quick before I forget. Let's do that, and we are going to uncomment that. Go ahead and rebuild it. Okay, so it didn't work because one of the things that you can do, which is really nice, is, so right here we're stating the only way to hit this is with a GET request. That is the only way that we're going to actually be able to hit this endpoint. So when I tried to send a post request, that's why it didn't work. Anyways, so if we go up here, let's look at, for example, ping. So this ping is basically as simple as it gets right here. All it does is print out that we received a ping. We are building a response here that is literally just going to send status code OK and a body that just has Pong in it. So that's all this is really doing. We are attaching this function as an asynchronous callback to this route. So anytime we hit this route with a GET request, we're going to run this function. That's very, very simple stuff. If we look, there's a more complex one. We look over at get mal. Right here, this one's a little bit more complex. So we're creating a file path here. This is just the path that cargo outputs the executable whenever I build it for that target. And that is where we're trying to pull the most updated version of the malware. This is in part a way that I can more easily debug the malware, so I can very quickly build it and then pull it down on the victim machine. But it's also sort of kind of how things work in real life. You'll just have some sort of route that will serve the executable for other folks to download. So this is basically making sure that we can in fact read the entire file. If we can't, we send back an internal server error, which will be a 500 error, and we send that body. This stuff doesn't matter as much, but it's useful for debugging. And here we are building the actual response for when things do work correctly. We've got an application octet stream, which I believe is just a catch-all for any kind of binary data. And then we are building a body from that buffer that we used to hold the file itself. So this file open here. And if we have an error with that, then we're going to return a service unavailable, which means that the server went down, which should never happen. But we're doing a very, very similar thing with getbg. We're just doing an image/png instead of basically an image/png instead of an octet stream. And we are opening up this background.png and we are sending that along with our successful request. So again, these are all things that you would see on a normal web server, because functionally a lot of the stuff that you see threat actors doing with these C2's, it's just normal web server stuff. It's nothing really fancy. It's nothing complicated. That said, there are some things that I do want to start implementing within this that are a little bit fancier. For example, WebSockets. So whereas a normal REST API works based on, one request equals one response, back and forth, WebSockets opens up a full communication channel that is ongoing with the victim, so you can get real-time information. This is where you can start logging keystrokes in real time. You can start, basically doing all kinds of fancy spy stuff on the user in real time. I want to start experimenting with WebSockets because I want to implement them within some of the backends of the enterprise SaaS applications that I'm building, but it's also kind of a cool thing for a lot of this, newfangled malware to do, is to have this WebSocket communication open so that, you've got that real-time, event stuff. There are also, I want to be able to obviously inject commands. So my plan there is to have a route that reads commands from either a raw text file or from a database of some sort that I can write into in order to send commands. And then once WebSockets works, then I'd like to be able to open up a full connection there. Some sort of reverse shell or something like that. So I've got lots of really interesting plans for this that I'm really looking forward to implementing. But at the very beginning, if you're kind of starting to learn about malware development, start off with the REST API because it's dead simple to implement. It's very, very easy to do. I've got it implemented in like under 100 lines, I think, maybe just over, about 86 lines. So it's very, very easy to implement. It's definitely doable. And it's a good way to kind of start. And a lot of threat actors don't move past that. They just basically have a simple REST API out there that they're using to communicate with their malware. So you'll see it out in the wild as well. That's about it. Everybody's been enjoying the malware development stuff, which is great. Take it easy. Peace.